In this tutorial, we will build an online first contact screen using SwiftData. You'll see real records in the list in a minute, and we'll begin to design the model and also sync to Firebase later. So this is the app at the moment. I'll now show you Firebase. You can see there's no records there. So now I will create a few records. That's the first record. But I will disconnect the Wi-Fi so that the data isn't pushed to Firebase. I now save the record to SwiftData. I'll create another record. And save again. And you can see that the records have not been persisted, they haven't been sent to Firebase because we're not online at the moment. So now what I will do, I will stop the simulator and then rerun it. And then now I will attempt to push the records to Firebase, the two records, which are at the moment stored offline. So I just pull to refresh. Oh, I've forgotten to turn the Wi-Fi on, but that's a good test anyway, so you can see that it really works. I pull to refresh it again. I think there's something wrong with the Wi-Fi. Has it worked now? So let's check Firebase. And now you can see, if I click on Contacts Collection, now you can see that the two records were submitted to Firebase. My record and also Fred blogs. And we can also delete the record from SwiftData, and the records will also be deleted from Firebase. Just refresh. You can see now it just includes my record only. The first file we need to create is our contact entity. So this will be a Swift file. Just name it contact entity. Click on create. Import SwiftData. SwiftUI. And then we just create our model at model. Final class. Contact entity. At attribute. Which will be unique for the ID. Also has a name or string, an email, string, and phone, a string. We also need to create a few other variables, which includes updated or update at, which is date, var created at date, is deleted, which is bool, var sync status, which is raw. It's raw. The name of the variable is sync status, but the data type is int. So this is our local database record at model, which means the Swift data will persist. As I mentioned before, ID is unique, so we can merge and avoid duplicates later during sync. And we also have the other field names, as you have seen, such as name, email, and phone. So the next thing we need to do, we need to create our initializer. Check in to see if it's correct. Self.id is equal to ID. Name is name. Email. Phone. Updated at is updated at. It all seems correct. But in the init method, the initializer, that should be equals UUID. And then we get the string version of UUID. Everything else is correct, I think. Or we can just add for the name, just blanket, and the email. Do the same for the email. Created at update data type, so we need to assign it. Good practice to assign it a default .now. And the same applies to this one as well. .now is deleted. False. And sync status. I think we're missing something. Sync status. Sync status, where is it? So within the initializer, sync status raw should be it's the wrong variable name, and also it's the wrong data type, so that should be sync status, which is the data type should be sync status equals dirty, which sync status doesn't exist at the moment. That will be an enum which we'll create later. And also on this line 31, that should be sync status dot raw value, but we'll create that later anyway. The defaults here are deliberate. Every record gets a UUID. Timestamp defaults to now. And the most important thing is that new contacts default to dirty, meaning not uploaded yet. So the moment we add Firebase, or we add it to Firebase, we already know what needs to be pushed. Now let's just create the enum sync status, which is int case sync equals 0, case dirty equals 1, case pending delete equals 2. So as I said before, 1 is local edits that haven't been pushed to Firebase as yet. On line 31, that should be sync status raw. So this enum that we just created is our sync queue. So dirty means that local changes have not been pushed. And pending deletes means that the actual records needs to be deleted later remotely. So the next thing we need to do is to create another struct. The name of this struct will be called contact DTO. Struct contact DTO, codable, sendable, let ID equal string, let name string, let email string, let phone, which is also string data type, and also created at date, update at date, and is deleted, which is bool. So DTO stands for Data Transfer Object, and this is what goes to Firebase. This separation stops your app from becoming tightly coupled to Firebase, which is a good thing. So now we will start to implement some of the UI just to show something on the screen. So we will implement that using content view. I just copied and pasted the content view just to reduce the length of the video. So as you can see, we import SwiftData, but really this will be refactored later so that it uses a repository and MVVM. But at the moment, we're doing all of the fetching within the content view, which is incorrect. But just for a quick demo. Yeah, so we're using the environment objects, and the purpose of that is to give us access to SwiftData context so we can insert and save the contacts. And we are also using a query. So this is the actual main line that performs the lookups within the or for the view, and also to sync the data automatically. And we also filter out deleted records as well. So as you can see, there's no fetch calls, no manual refresh. SwiftData does it for us. And then here we actually render the contact list as well by looping through the records within the array. And for demo purposes, we hard code an array here that will be stored within SwiftData. And that's called by clicking on the seed button. So in the next part, we will create the edit and delete property of the UI and the MVVM model, so that later we can plug it all into Firebase without rewriting everything. So that's for the next tutorial. If this topic is where you keep getting stuck in SwiftUI, that's exactly what I help people with in one-to-one mentoring. There's a free Clarity Call link in the description